to ensure that the part will be processed according to the most economically possible way determined through process planning. Also, the process documentation and corresponding communication provide a basis for improved part consistency and quality in manufacturing. Thank you for watching. If you like this channel, subscribe, share my minds and...
Okay, this video is finished. And we have learned something. It mentioned something of process and process rule, and also some basic concept we have learned last week. And okay, this video.
Searching for a better way to collaborate with your team? Try Miro, an online whiteboard made.
Sorry, this video is too long and we haven't enough time to see it. Maybe we'll see it later if we have enough time. So we have learned something about process rule and the definition of process rule and the functions of process rule, including 4 aspects. The document to get production course, basis of production preparation, important technical reference to build a new factory or rebuild a former factory, and the main means used to store and exchange knowledge. So we have learned the process rule and the functions of process rule. The next question is, what material are needed, are required in process planning? In most cases, the manufacturing process for a given part or product is not unique. The task of process planning is to find the most reasonable process route among the candidate ones. For this reason, process planning techniques must connect original material related to this part and the product as detailed as possible. The material, the original information required to make out process rule can be concluded like this. The first one is part join and assembly join of the product. The first step is join something, including the part join and the assembly. Next one is production program and the production type. The production program and the production type we have mentioned last week. And the third one is the quality standards used to inspect products. And the fourth, blank production situation. Blank part, blank production situation. Blank part comes from raw materials, and the fifth is production condition of the factory. And the last one is development of current production technique at home and abroad. So, the original information required in process planning include 6 contents. The first one is joins, the part and assembly joins of the product. And the Second one is a production program and a production type. We have mentioned last week. And the third one is quality standards used to inspect products. And the fourth is blank production situation. And the fifth one is production condition of the factory. And the last one is development of current production technology at home and abroad. So up to now, we have learned the process rule and the original information required in process planning. So the next question comes out naturally is what the steps, what the procedures of process planning, how to conduct process planning, which means what the steps of process planning, because we have learned the definition of process rule and its functions and the original informations. We have so many things, we have so many knowledges. So the next question comes out naturally is how to conduct process planning. What's the first step and what's the second step? The next PPT is to show this. The first one is technological analysis of the work part to be machined. Analysis of the work part to be machined. The primary task of this step are to analyze the structural manufacturability, technical requirements, production type, and so on. The first step of process planning is technological analysis of the work part to be machined. Technological analysis of the work part is the first step of process planning because the primary task of this step are to analyze the structural manufacturability, technical requirements, production type, and so on. And the second step is selection of blank. Is the beginning of the process planning because the types of blanks and their quality have great influence on process planning. Therefore, the fabrication method and the accuracy of the blank should be specified based on the function, the production program, the mechanical properties, and the structural features of the part before process planning. So the second step is selection of blank. The first one is the technological analysis of the work part to be machined. And the second one is the selection of blank. Because the blank have great influence on the process planning. And the fabrication method and accuracy of the blank should be specified based on the function, the production program, the mechanical properties, and the structural features of the part before process planning. The third one is drawing up process route. Drawing up process route during the planning. This step is a critical step in process planning. It includes selecting location data and process methods, dividing machine stages, arranging machining sequence of each surface, determine the degree of process concentration, and process disposal, arranging heat treatment, inspection, and other actionary operations. So what we must know is the third step is join up process root. And the fourth one is determine equipment and tunings needed in each work operation. Tuning is a general name of cutting tools, fixtures, measuring instruments, and actionary tools. The production type, the structural features, and the requisite machining quality of the part should be considered in selecting machine tools and tunings. Sometimes, the design task of a special purpose equipment and tuning is put forward if necessary. As mentioned, the first step is determine equipment and tuning needed in each working operation. The next one is specifying technical requirement and inspection means used in the key operation. Technical requirement and inspection means in the key operation. And the next one is determine machining allowance. Calculating operation dimensions and their tolerance for each operation. Allowance, calculating operation dimensions and their tolerance for each operation. And the next one is specifying cutting variables for each operation. Because in order to simplify process document and production management, the specific cutting variables are not specified clearly in process sheet but decided by operators themselves according to specific production condition in job and small production. In medium volume, especially in large volume and mass production, in order to ensure production balance and machining quality, cutting variables are specified clearly in operation sheet and not allowed to modify them later. Specifying cutting variables for each operation. Specifying cutting variables in each operation. Because in order to simplify process document and production management, the specific cutting variables are not specified clearly in process sheet but decided by operators themselves according to the specific production conditions in job and small volume production. In medium volume, especially in large volume and mass production, in order to ensure production balance and machine quality, cutting variables are specified clearly in operation sheet and not allowed to modify them. The next one is identifying time standards. The ninth is performing technical and economical analysis. The last one is filling in process sheet and other document that would be used by operators. So based on the definition of process rule and the original information required to make out process rule, we have named the steps, the procedures of process planning. And I will mention it again. The first one is technical analysis of work part to be machined. Because the primary task of this step are to analyze the structural manufacturability, technical requirement, and production type, and so on. The second one is selection of blank. Because the blanks have great influence on process planning, the fabrication method and the accuracy of blank should be specified based on the function, the production program, and the mechanical properties and the structural features of the part before process planning. The third one is drawing up process route. This is a critical step in process planning, including selecting location data and process methods, dividing machine stages, arranging machining the sequence of each surface, determine the degree of process concentration and process disappear. The fourth is determine equipment and tuning needed in each working operation. Equipment and tunings are determined in the fourth step. And the fifth is specifying technical requirements and inspection means used in the key operation. Specifying the technical requirements and inspection means in the key operation. And the next one is determining machining allowance, calculating operation dimensions and their tolerance for each operation. And 7, specifying cutting variable for each operation. Usually, in order to simplify process document and production management, the specific cutting variables are not specified clearly in process sheet, but decided by operators themselves according to specific production condition in job and small volume production. In medium volume, especially in large volume and mass production, in order to ensure production balance and machining quality, cutting variables are specified clearly in operation sheet and not allowed to modify them. The cutting variables are specified clearly in operation sheet and not allowed to modify them. In large volume and mass production, in order to ensure production balance and machining quality. The next one is identifying time standards. The ninth is performing technical and economical analysis. And the last one is filling in process sheet and other document that would be used by operators. So it's time to have conclusion. We have learned the definition of process rule. The definition of process rule is in the form of document, in the form of chart tables and words that relevant content to the manufacturing process of a product specified in the form of document, in the form of chart, tables, and walls. And this is process rule, its definition. And then the four functions. Main technical documents used to guide production costs. First one, and the second, basis of production preparation. Third one is important technical reference to build a new and rebuild factory. And the first one is main means used to store and exchange technology. So it is a function of process rules. And what's the original information required in the process planning? The first one is part join. So we have 6 content. The first one is part join and assembly join of the product. And the second one is production programming and the production type. And the third one is quality standards used to inspect products. The first one is blank production situation. And the fifth is production condition of the factory. And the sixth one, the development of current production technology and at home and abroad. So based on the concept definition of process rule and the original information required, the question is how to conduct process planning. What's the steps? What's the procedure of process planning? We have mentioned 10 steps. The first one is technical analysis of work part to be machined. The second one is selection of blank. And the third one, join up process route. The fourth one is equipment and tuning needed in each working operation. The fifth one is specifying technical requirements and inspection means used in the key operation. 6. Determine machining allowance, calculating operation dimensions and their tolerance for each operation. And the next, specifying cutting variables for each operation. And is identifying time standards. 9th, performing technical and economical analysis. Technical and economical analysis. And the last one is filling in process sheet and other documents that would be used in operators. So it's time to try break. We will come to class at 10 o'clock. Let's have a break.
Okay, we'll see. Okay.
Okay.
return.
Yes.
None gahunda rimeze bite?
Umve. Je ntanguye kwitegura.
Ubu ngubu nibwo ugitangiye.
Ndatanguye nyene no kwisiga.
Uzi ko hariya kwagera ari saa mani?
None tuva ngaha saa 10 je nkeneye gusanga inyama zahiye.
Mani nibwo biba bitangiye aho kuki umeze gutya?
Bro.
Ni
Everyone,
isomo adatangiye uca.
the class will be start at 3:10 o'clock, 5 minutes later.
Okay, now, shoot.
Guys, be quiet, be quiet.
Ты быстрее, дача.
So let's back to the class. And I will show my screen.
Yes, sir.
Okay. So the last class we have learned the process rule and the original information required in process planning and the procedure of process planning. And I won't mention it again. But what I want to say is most of the key points I have mentioned will be shown in the final examination. Something I have mentioned a lot of time, and the key point may be shown in the final examination.
Yes, sir.
So please pay attention to the class. So let's.
老师，
The next chapter. Okay, next chapter. This time we will talk about selection of location datum. So the first way we want to know is what is datum and how many datums should we know. The first one is what's the definition of datum, which means points, lines, or surfaces used to determine the position of other points, lines, and surfaces on the same workpiece are called datum. So the definition of datum is point, lines, or surfaces used to determine the position of other points, other lines, and surfaces. According to the function of datum and the used situation, datum can be classified into design data and process datum. So let's introduce them separately. The first one is design datum. It refers to the point, lines, or surfaces that are used as references by the designers to mark dimensions and relative positions of other graphic elements in engineering drawings. In other words, design datum is the starting position. Used to label the dimensions of workpiece. So maybe we join something, drawing a part through a software, SolidWorks or Pro-E, engineering or Creo, and something else. The design datum may be used in the drawing process. It refers to the point, lines, and surfaces that are used as references by designers in the drawing process to mark dimensions and relative positions of other graphic elements. To mark other elements in engineering drawings using the software may Pro-E, SolidWorks, and Creo, UG, and so on. Design datum is the starting position used to label the dimensions of workpiece. So let's see example showing this figure. The center line of the gear is the design datum of the cylindrical surface with diameter super D and D0, and the inner cylindrical surface of the diameter d, where the end surface A is the design datum of the surface B and C. Since the position of B and C are determined by the surface A, so we use the surface of A as a datum, and then we use the dimension like a small h to locate the surface C, and use the dimension h to locate the surface B. So the surface A is a datum to locate surface B and C. So we have then the design datum, which is used in the drawing process. You throw some software like this one, or maybe there is video. We can see this one.
Question: would you build a website for a major brand with more than 200 million?
All right, everyone, let's consider a simple part with some datum features specified. Here in this drawing, you can see that the most crucial surfaces of this part, the most crucial aspects of this part are the leftmost surface, denoted by datum feature A, the bottommost surface, denoted by datum feature B, and the 2-inch width, denoted by datum feature C. Okay, we see these datum feature symbols on the drawing. They're connected to extension lines leading to the respective surfaces. And in the case of datum feature C, it's connected to the dimension line, denoting the width of that dimension. So we know what the most crucial surfaces are in this part. This part is going to assemble, contacting that leftmost surface, contacting that bottommost surface, and then being centered somehow. So considering that, we have the question: how can we best simulate final assembly in manufacturing and measurement? And how can we base all the other features, all the other surfaces, as denoted and labeled on the drawing? How can we base those other surfaces off of the most crucial surfaces, datum feature A, datum feature B, and then the midplane C? How can we do that? It might seem simple. Well, just machine from those surfaces. Machine from datum feature A and datum feature C when you are making those other surfaces. And then just measure from those surfaces. Measure from datum feature A, measure from datum feature B. That seems pretty simple enough, right? Datum feature A and datum feature B, they look pretty good, right? They look like straight surfaces, straight lines. We should get some good measurement, some good manufacturing of the other surfaces from going based off the most crucial surfaces. That's what makes sense, right? But let's look at datum feature A and B on a microscopic level. These surfaces are actually imperfect, right? They lead to inconsistent results because they're curvy, they got indents, they may even have cracks or nooks, right? They're unlevel. Measuring from this kind of surface, it's going to lead to inconsistent results. And another problem that we have is that just measuring from that surface, we're not really simulating final assembly. Let me try and illustrate this. If we were to put this part into assembly, we would see that the imperfect surfaces of datum feature A and datum feature B, they're contacting on their high points of those crucial surfaces. They're contacting on the high points, right? So if we were to just measure from these surfaces, we're not really going to simulate a assembly well. How we can simulate assembly in our manufacturing and in our measurement is actually doing the manufacturing from the geometry that's created from the high points of these most crucial surfaces, datum feature A and datum feature B. How we can simulate final assembly and measurement is that we measure from that plane that is created by the high points of these surfaces. That's what we can do it. That's how we can do it, because at those high points, that's where contact is happening, right? If we were to measure from that point, we're measuring those features, those other surfaces, as if this part was assembled, right? We're doing it as if it was assembled. So what are these theoretical geometry called? What are these planes called that contact the high points? These geometry that connect the high points, that simulate this final assembly of parts and part features and features of size, those are called datums. That's what the datums are. It's that theoretical geometry that we can't see. It doesn't actually exist. It's something theoretical that we use to get accurate measurements from the most crucial surfaces and to simulate final assembly, to simulate those surfaces in final assembly.
Are you an engineer or a
Okay.
product developer?
Okay, we have named the design data. The first important concept, design data, which can be point, line, or surface used as reference by designers to mark dimensions and relative positions of other elements. In engineering drawings. So we have to take the example and through the video. So in this example, in this figure, the datum of this circle dimension d and d0 and small d, the center line is the design datum. We use the center line to calculate this dimension. Use this center line to estimate this dimension and also this dimension. So the center line is the design datum of this circle, this cylindrical, and the surface A is the datum of surfaces B and C. We locate surface A and use the dimensions h to locate C and B. Use this one, maybe h. To locate, we use A and the dimension h to locate surface B. So we have mentioned the design datum. The next one is process datum. Process datum used in the machining or assembling process. Machining or assembling process are called process datum. According to the function of process datum can be further divided into operation, location, measuring, assembly datum. So compared with design datum is more basically datum used in the drawing process. And the process datum is used in the machining and assembly process. And it can be divided into operation datum, location, measuring, assembly datum. The first one is process datum. is operation datum. The datum used in the operation join or process file to determine the positions of surfaces to be machined in one operation are called operation datum. The dimensions marked on operation joins are referred to as operation dimensions. This is the definition of operation datum. It is used in operation join and process file to determine the positions of surfaces to be machined in one operation. In one operation is a key point. Determine the positions of surfaces to be machined in one operation is called the operation datum. For example, in this figure 3.7, a hole is to be machined on the sleeve. Both L1 and L2 are called the operation dimension for the hole drilling, but the surface A is operation in the left figure. We use surface A as the operation datum to drilling this hole. And in the right side, the surface B is the operation datum. We use the surface B and the dimension L2 to locate the location of this hole. The second one is location datum. It is used to determine the correct position of workpiece on machine tool or fixture is called location datum. Location datum is used to determine the correct position of workpiece on the machine or fixture is called the location datum. Determine the correct position of workpiece on the machine tool or fixture is called the location datum. For example, in this figure, this symbol is used as location datum. And this symbol attacked which surface, which means this surface is used as a location surface. Generally, location datum can be further classified into rough, raw datum, and finished datum. While the location surface which has not been machined is called rough datum surface or rough datum, while the location surface which has been machined is called finished datum. So the difference between rough datum and finished datum is whether the location surface is machined or not. When it has not been machined is called rough datum, and when it has been machined is called the finished datum. Location datum used in the first machining operation must be a rough datum because it is used in the first machining operation. We haven't machining this part, and it must be a rough datum. Finished datum are also divided into major finished datum and auxiliary finished datum. While the major finished datum is just the functional surface of workpiece, whereas the auxiliary finished datum has not any function in assembly join and is machined specifically for the location of workpiece. For instance, the center hole at the ends of shaft. Are the auxiliary finished datum because it is used to locate the workpiece. It has not any function in assembly join. The third one is measuring datum. The point, lines, and surface on which the measurement of the position of machined surface is based are called measuring datum. The third process datum is the measuring datum, which means the point, line, surfaces which the measurement of the position of machined surface is based are called the measuring datum. Usually, the design datum can be selected as the measuring datum, but when it is inconvenient or impossible for the design datum to be used as the measuring datum, we should choose other surfaces existed practically on the workpiece as the measuring datum. For example, the center O is here. Center O is here. E of a circle is a design datum of surface A in here. And L, dimension L, is a design dimension. But after surface A is machined to a plane, point C, located here, is selected as the measuring datum to measure the dimension L1, as shown in the right side. Because we use this tool to measure the dimension of L1, we must use the surface of surface C. Because the center O are hard to get, hard to achieve, so we use surface C as the data to estimate the dimension L1. So the first one is assembly datum. The datum used to define the relative position of a part or sub-assembly in a product in assembling process is called assembly datum. The first one is assembly datum, which is used to define the relative position of a part or sub-assembly in a product in assembly process is called assembly datum. Assembly datum is generally consistent with the major design datum of the worker part. So we have named the definition of datum, it can be classified to content. The first, the datum is defined by point, lines, surfaces used to determine the position of other points, lines, or surfaces on the same workpiece are called datum, and it can be classified to contents. The first one is design datum. It refers to the point, lines, or surface that are used as a reference by designers to mark dimensions and the relative positions of other elements in engineering drawings. And the second one is process datum, and it can be divided into operation, location, measuring, assembly datum. And we have introduced them one by one. And examples. So it's time to have video. See datum and its classification.
I think we should explore a few solutions.
Grammarly suggestions can
B. How we can simulate final assembly and measurement
We have
is
seen this
that we
before.
measure from that plane that is created by the high points of these surfaces.
Because we have seen it before and we will see it again to save time. So we have learned, up to now, we have learned the datum and the classification of datum, which contains, conclude the design datum, process datum, and the process datum can be classified, can be divided into 4: operation, location, measuring, assembly datum. So the question come out naturally is how to select the location datum. What the principle of selection of location datum? To select location datum is the first step in drawing up the machining process. The selection of the location datum is of primary importance for drawing up reasonable process route and for designing fixture with proper structure. Also, it affects the machining accuracy, productivity, and the production cost of the workpiece to be machined. In the selection of location datum, 2 issues should be considered simultaneously. The first one is which surface on the workpiece to be chosen as the finished location surface can effectively ensure the machining accuracy of the workpiece, whether there is any individual operation which requires the second finish datum. And second, in order to machine the finished datum mentioned above, which rough surface should be selected as the rough datum. As the function of the rough datum is different from that of finished datum, the emphasis considered in specific selection is different. So it comes out the first principle of selection of location datum is principles of selecting rough datum. Principle of selecting rough datum. When selecting rough datum, emphasis is to consider how to ensure the multiplication relation between machined surface and unmachined surface, and how to ensure each surface to be machined has an adequate machining allowance. The principles of selecting of rough datum. The first one is giving priority to the guarantee of the mature position requirement between two surfaces. If the relative position between the machined surface and unmachined surface must be met, the unmachined one should be chosen as a rough datum, and when there are several unmachined surfaces in the workpiece, the unmachined surface, which has higher position requirements relative to the machined one, should be chosen as rough datum. For example, as shown in this figure, the cylindrical surface 1 is an unmachined surface. For example, the cylindrical surface 1 is an unmachined surface. In order to achieve even wall thickness, the surface 1 should be chosen as a rough datum when turning the whole 2. Although there are several unmachined surfaces, outer cylindrical surface, which is 40 mm, should be selected as a rough datum so that the causality of the hole and the outer cylindrical surface can be ensured. So which means the first one, we should give priority to the guarantee of the mature position requirements between two surfaces. The second principle is giving priority to guarantee the machining allowance. Giving priority to the guarantee of machining allowance. If the machining allowance on an important surface must be adequate and uniform, the surface should be selected as rough location surface, which means it will be machined later, maybe the last one, because the machining allowance on this important surface must be adequate and uniform, which means it is important. The important thing always are machined later, maybe in the last process. So the second one is giving priority to the guarantee of machining allowance. And the third one is reliable location. What does it mean? It is preferable to choosing a flat, smooth surface with larger contact area as a rough location surface to guarantee the accurate position and reliable clamping. Surfaces with casting gate, razors, flashes are not allowed to be chosen as the rough location surface, because the reliable location are the priority to choose a datum. It is preferable to choose a flat, smooth surface with larger contact area as a rough location surface to guarantee the accurate position and reliable clamping. Otherwise, surfaces with casting gate, razors, and flashes are not allowed to be chosen as a rough location surface. And the last one is don't use rough datum repeatedly, because finished datum should be used as far as possible if there haven't been. Generally speaking, it is not allowed to use the rough datum repeatedly in the same dimension direction. Otherwise, it is hard to ensure the mature position accuracy of surfaces in two locations. The first one is don't use rough datum, because use the rough datum repeatedly in the same dimension direction. Otherwise, it's hard to ensure the mature position accuracy. Of surfaces in two locations. Up to now, we have learned. We are recall what have we have learned. We have learned the definition of datum, including design datum, process datum, and the process datum can be divided into operation, location, measuring, and assembly datum. Operation datum, location datum, measuring datum, and assembly datum. And we have learned how to select a rough datum. As we mentioned, the datum can be divided into rough and finished datum. And this time we have learned the principles of selecting rough datum. And the next question comes out naturally. How to select a finished datum? The first one is datum coincidence principle. The first one is the datum coincidence principle. Datum coincidence means generally to select design datum or operation datum as location datum. Generally select design datum and operation datum as the location datum. To use this principle can avoid the location error caused by the non-coincidence of datum. It is better to follow this principle when the operation machining accuracy is very strict. And the second one is the datum unification principle. This principle means selecting a group of surface as location datum to machine most or all surface of a workpiece. The second one principle to select a finished datum is datum unification principle. This principle means selecting a group of surface as location datum. A group of surface as location datum to machine most or all surface of a workpiece. And the third one principle to select finished datum is principle of mature location datum, which means the surface A is used as the finishing location datum to machine surface B firstly. A used as a finish location first to machine surface B, and then surface B is used as location datum to machine surface A, which means mature location surface first use A to machine surface B, and then inverse, we use surface B to machine surface A. This principle is used to machine two surfaces which have the higher mature position accuracy. Because this principle is used to machine two surfaces which have the higher mature position accuracy. And the first one is self-location datum principle. Self-location datum principle. Self-location datum means using the surface to be machined. Using the surface to be machined as its own finished location datum. In finished machine, the surface to be machined itself is selected as finished datum in order to remove a small and uniform machining allowance from the surface. And the fifth one, the last one is convenient for location and clapping. The finished location surface, especially the primary location surface, to be selected should have a large area and adequate precision in order to ensure the correct and reliable location and be helpful for simplifying clapping mechanism and convenient operation at the same time. So we have named the datum, this class.
Yes,
Just now, we have named the principles of selecting finished datum and the principles of selecting rough datum. We have introduced the definition of datum and the classification of datum, including design datum, process datum. Process datum can further be divided into operation datum, location datum, measuring datum, and assembly datum. They are all the key point of this class. And the next one is the selection of location datum. We have gave out the principles of selecting the rough datum, which contain 4 aspects, and the principles selecting the finished datum, which contain 5 aspects. If we know this knowledge, and the class is successful, and so monitor Sunny, can you hear me? Where is the monitor?
Yes, Laochi, I'm here. My microphone is far away, so
Okay. So it seems like someone recorded the class. Are you recording the class?
There's another monitor recording the class. We have 2 monitors in the class, so he's gonna upload the video on YouTube.
Please send the video to me of this class to me before you send it to YouTube.
Okay, Laoshi. Okay, no problem.
And we have some practice. Maybe the next we have so much thing to study. So the speed must be satisfied.
Yes,
And
Laoshi.
maybe this practice will be the end of the class, and I will give you my email address, and everyone should send the homework to my email, and which is contribute to the final score. And I want to emphasize again all the key points I said again and again and again, which are the key point, the content will be in the final examination.
Lashi,
Yes,
when
Laoshi.
what is the date for our examination?
It will be, you will be noticed through the WeChat group. Don't worry.
Laoshi,
Hmm?
please, can we have the PPT?
PPT? Yes.
Thank you, Laoshi.
Maybe I
Please, can
send
you send it to
to the monitor, or I send to the WeChat group after
Okay,
the
Laoshi,
class.
thank you.
Okay.
One thing I want to mention, do not plagiarism, do not cheat me.
Yes, Laoshi. We won't.
Write the homework by yourself, and everyone will have a high score.
Okay, Laoshi. Thank you.
Okay, Laoshi. Okay.
So it's time to have a break. Please come back at 4:20. Thank you.
Yes, Laoshi.
All right. Hey.
So let's back to class, and I will share my screen.
Okay, 老师。
Okay. So the next one is join the process root. Because we have learned the basic concept of production course last week, and just now we have learned the procedure of process planning, including process rule and its function and others. And the third one, the selection of location data, including data and its classification, and how to select data, the principles of rough datum and finished datum we have learned. So the next question is, we have learned so much, and how to join up the process root. This is then the question we will find the answer now. Process root refers to the sequence of parts across a related department or operations from blank preparation to the finished product packaging stage in the production process. So what is process root? It refers to the sequence of parts across the related department or operation from blank preparation to the finished product packaging stage in the production course. It is the sequence of parts from blank preparation to the finished product packaging stage is called the process root. It includes selecting the location data we have learned just now, and the processing methods of each surface, dividing machine stage, determine the degree of process saturation and the process dispersion, and so on. Now we will learn the selection of surface machining methods. Because the main topic of this class is join up process root, and the first one of process root is the selection of surface machining methods. It is very important. The topic of selection of surface machining methods is very important in the process root, and so it is first introduced in the class. When joining up machining process root, the machining methods of each surface should be firstly determined according to quality requirement for each surface on the part join. In the selection of a machining method of a surface, the factors that should be considered include the design and the processing feature, machining accuracy, surface roughness, and so on. The first one is selection of machining method. And the first one is economic machining accuracy and surface roughness obtained by different machining methods. First one is economic machining accuracy and surface roughness obtained by different machining methods. This is the first selection of the first step of selection of machining method is economical machining accuracy and surface roughness obtained by different machining methods. And the second one is the selection of machining methods and machining schemes. The first one is the economical machining accuracy and the surface roughness obtained by different machining methods. The machining accuracy and the roughness and surface roughness. And the next step is to select the selection of machining methods and the machining schemes. The step 2 is dependent on step 1, which includes the machining accuracy, some principles, and the surface roughness of different machining methods. And dependent this one, step 1, we comes to step 2, selection of machining methods and machining schemes. The final machining method should be determined according to technical requirement for the surface, and then taking the machining schemes of typical surfaces. First, the final machining methods and the machining schemes are selected, and then the material to be machined. And the third one is the production type. The last one, available production condition and technical level in your factory should be considered, which means 4 aspects are considered in the second step, which means the final machining method and the machining scheme. Second, the material to be machined. Third, the production type and the available production conditions and the technical. So we have named what is process route, and then the selections of surface of machining methods. We have named the process route. And the next question is how we to divide the machining phases. Generally speaking, it can be classified into 4 aspects, and the first one is, so the first question is why to divide the machining surface phases? In order to ensure the machining quality of the workpiece and to acquire high productivity and good economy. The process route is usually divided into several machining phases, and the first one is rough machining phase. In this one, the main task of this phase is to remove most part of the surplus material from blank efficiently and to prepare the finished location surface for successive operation. This is called the rough machining phases. It is the beginning of the machining process. The beginning of the machining process is rough machining phase, which means remove most part of the surplus material from blank efficiently and to prepare the finishing location surface and for successive operation. And this next one is semi-finishing machining phase. It is based on the first one. Go further, named semi-finishing machining phase. The main task of this phase is to make the major surface to get a certain accuracy level and to make a preparation for finishing this surface. In this phase, semi-finishing machining phase, the main task of this phase is to make the major surface to get a certain accuracy level and to make a preparation for finishing these surfaces. So the first one, rough, second one, semi-finish, and the third one is, second one is semi-finish, and the third one naturally goes to finishing machine phase. Except for the surface required for further polishing, all surfaces should be finished to meet the technical requirements stated on the part drawing. The third one is finishing machine phase. In this phase, except for the surface required for the further polishing, all surfaces should be finished to meet the technical requirement stated on the part drawing. And the last one is the burnish machining phase. Burnish machining phase. And the main goal of this phase is to decrease the surface roughness and to improve the machining accuracy at the same time. The last is burnish machining phase. And the main goal of this phase is to decrease the surface roughness and to improve the machining accuracy at the same time. So we have named the 4 phases of machining. And the first one is rough machining phase. And the main task of this phase is to remove most part of the surplus material from blank efficiently and to prepare the finishing location surface for successive operation. And the second one is semi-finishing machining phase. In this phase, we will make the major surface to get a certain accuracy level, and to make a preparation for the finishing this surface. And the third one is finishing machining phase. In this phase, except for the surfaces required for further polishing, all surfaces should be finished to meet the technical requirement stated on the part drawing. And the last one is burning machine phase. The main goal of this phase is to decrease the surface roughness and improve the machining accuracy at the same time. We have named the machining phase, which can be classified into 4 phases, and the reason for dividing machining phase can be shown as follows. The first one is to machine the finished datum surface in advance. Second, they perform rough machining firstly and the finish machining. Third, to arrange major surface and then the minor surface. And the last one, machining plan is in advance of home making. So this point is not important. So we will not go further of this point. So the next question is how we arrange the operation sequence, because there are a lot of operations, and how we arrange the operation sequence. Which one is first, and which one is second, and which one is the last one? There must be some principles, and the first one is arrangement of the heat treatment operation. Is a heat operation. The main purpose of heat treatment is to increase the mechanical properties, improve the cutting performance, and release internal stress. The arrangement of heat treatment in the process route of the workpiece mainly depended on the workpiece material and on purpose of the heat treatment. The arrangement of the heat treatment operation, the first one is preparatory heat treatment. And the second one is final heat treatment. Final, preparatory, and the last one, stress removing heat treatment. What I want to say is in this one, stress removing heat treatment. This is very important in machining process. Such heat treatment as annealing and aging are generally arranged before or after rough machining. For some large and complex casting, artificial aging is often arranged after rough machining in order to reduce the deformation caused by internal stress. Natural aging is generally arranged before roughening machining. Surface treatment can raise the corrosion resistance and wear resistance and improve the appearance. It is usually arranged in the last operation. So the next one is the selection of machine. Which machine should we choose? It must have some principles to guide us, to get engineering to select the machine. The first one is the precision of the machine tool should be able to meet the precision requirement. The precision of the machine tool should meet the precision requirement for the workpiece. And the second, the machining range of machining tool range and tool should adapt the counter size of workpiece to be machined. And the third one, the power stiffness and working parameters of machine tool should meet the requirements of the most rational machining material variables. And the fourth, the production efficiency and the machining tool should adapt the production type of the workpiece. And the last one, the existing machine tool in your factory and the domestic machine tools should be used as far as possible. So we have learned something in this class. Just now, join up the process root, including. I only show you the key point of this class. We have learned the selection of surface machining tools, the join up the process root, include the selection of surface machining methods, which include two aspects. The first one, economic machining accuracy and surface roughness obtained by different machining methods. And the second one is selection machining methods and machining schemes. And then we introduce the division of machining phases. Because there are many steps in the machining process, the machining process can be classified into rough machining phase, the semi-phase, finish machining phase, and the finish machining phase, and the last one, burnish machining phase. And then something else, arrangement of operation sequence. This part is arrangement of heat treatment operation and the selection of machine, which include 5 aspects, which means the precision, the first one. The second one is the machining range of machining tool, and the power, stiffness, and the working parameter for the machine tool. And the first one is the production efficiency of machine tool, and the last one, the existing machine tool in your factory and the domestic machine tool should be used as far as possible. So most of the contents of the class have finished, and then it comes to the homework. Does everybody hear?
Yes, Lashi.
Yeah, Lashi, we are here.
Okay, first I want to say is, who can send this video to me through the email? This video is the last class. And who sent this one to YouTube?
Is the other class monitor email? Why is there a problem?
Can he send this video to me?
Okay, I will tell him to send it.
Okay. It seems he doesn't come to class today.
Oh, he's here. I don't know. Email.
Oh, you are here? Oh, please send this video. And do you have the video in your computer? Or you have deleted it?
No, of it's we uploaded in YouTube, so anytime you can get it.
Oh, but it's hard to download the video.
Yes, Lash, he'll send it to you. Don't worry, he'll send it to you.
Okay. Please send it to my email address.
Okay.
And We have lots of practice homework showing in this PPT. And please, one thing I want to say is last class, one female student sent me the homework, and the homework is write by herself, by hand in herself, write, and it is written on the paper. And I think that homework is very good. And
so Raj, you want us to write with our hand?
On computer is okay, and write on hand is okay.
Okay.
All fine. And today we have and all of this all of this I have mentioned before just now, and most of them I have mentioned again and again. And this now, please write it down in Microsoft Office, means Word, or write it on hand. All the means is okay. And then send it to me. And we have I see we have, maybe you have, I see, please send the homework of last week, send it to me this time, and it may be I will contribute to the last score.
Okay,
send the homework of last week to me this time.
你好，老师。
Together with this one, and name the file with your name and student ID, so I can find you. I will know who are you.
Last week homework is the one you said we should write the definition for this.
Yes. Some students have sent it through WeChat. And please send the homework again together with today's homework to this email.
Okay, Lashi, today's homework we should define these words, right?
Yes. Okay. To explain these words.
Fantastic.
And no plagiarism. Do it by yourself.
We have to do it now, Lashi.
Okay, Lashi.
Yes, we have 20 minutes to finish it, to do it now. And if someone finished it and want to share it with us, and will be contribute to the final score. And we have 20 minutes. Okay.
Okay, Lashi, can you please send PPT?
Send the PPT.
Yes, for this course.
Maybe this time we have screenshots, and after class I will send the PPT to the WeChat group. Okay.
Okay, Lashi.
Lashi, the guy with the video is here. You can talk to him. His network was unstable, but I think it's okay now.
Sorry, Lashi, my network is unstable. That's why. Yeah.
Hello, Lashi. He has the videos.
Videos.
Said you should send him
to this email.
This email, but the file is very big. It won't be sent this email, and it will be sent via through Drive, not directly in email. Can I send you in a WeChat?
Okay. Send me. It's okay. And at 5:10. We don't have enough time, and this time. So we have 20 minutes to finish to do the homework. And if you don't finish it, and maybe you finish it after class, and send them. And after you finish the homework, send the homework including the last one, the homework of last class, send it to my email address.
Laoshi, why don't you let us just do it after class? I think that way is better.
Yeah, that
So
will be much better.
read the whole PPT, understand again, then we define them.
You want to see the PPT again?
I think it's better the
can-
homework we do it after class so that we can read the
Yeah,
PPT
yeah.
again, and then because if we do it now, we
Maybe just
copy your own.
maybe now you write it by yourself, and after 10 o'clock we finish the class, and I will send the PPT to the
PPT.
WeChat group.
还可以，
Yeah.
谢谢。
老师，
你说，Ugu.
Maybe I can explain the first stuff and
I cannot
in the
hear
meantime.
you clearly.
Can I explain the process route?
Process route. So what's your name and student's ID? Maybe you
62.
in the chat room. Maybe you
Yeah.
type it.
Yeah. I sent.
Okay, 62. Oh, okay.
Yeah. So when we say routing, the process of routing, it means determination of a route to be followed by each part or like in any component being transformed from input. When I say input, it also means like raw material. So it means the route to be followed by each part or a component being transformed from the raw material into the final product. So obviously where one single part or product is produced by fixed set machine, the job of routing becomes, automatic or machinized in a continuous production system with line type or product type layout. No managerial effort is required for routing through different sets, so of machines maybe utilized in manufacturing the product in such systems. So it is the route followed by each component being transformed from input into final product. Yeah.
Okay. So where you found the answer? I haven't told you so much.
Yeah, like we are university, so we have to make our own research.
Okay, I have read down your name and the student ID. That's other student and if you finish all of them, you can share with us.
Laushi, are you here?
Yes, I'm here.
What will be the question pattern of our final examination?
What?
What will be the question pattern? That is, how many questions will be there in the final exam?
How many? What?
How many questions in the final exam?
I don't know now, but it may be very simple. Difficult.
one is about principle of machine learning. Yeah.
Okay.
To share the screen. I don't think it's more complicated. I just stop here.
You want to just screen?
I can share this device.
Okay.
Okay. So what machine like domain equals to input. So on machine work on principle that when the effect when it is smaller than the load, it has the move a greater distance in order to continue the same work. I mean, like when the effect is more effect is more in the work and at a heavy load, so it moves a greater distance in order to achieve the same work. And then like for one then it should be so the machine process plan, it should be like in discrete manufacturing involved a number of decisions such as design, interruption, and selection of material, maybe selection of machine operation, maybe machine tools and cutting tools, serial planning, and then the selection, determination of cutting condition, so on. And no, let me just a minute. I'm going to. I just want to talk about like full type of manufacturing process. It's called setting and molding, machining, joining, and shape of forming. So machining is one part of manufacturing process. Yeah.
Okay. Have your and name. Three. 77. Someone have where are you? Everyone will have a high score if you finish the homework in high quality. You have to see the question now and expand on the homework in the need.
I discuss about heat treatment operations.
Okay, you announce one share. Let's begin.
Okay, I don't want to share this screen because sharing screen is a bit complicated.
Okay.
Okay, for the in order to improve the viability and competitiveness of precision machining enterprises among manufacturers, the key is to rely on advanced technology, and for this heat treatment is required. There are two types of heat treatment. The first one is the preliminary heat treatment, and the other is the final heat treatment. And for these heat treatment operations, for preliminary heat treatment, the purpose of the preliminary heat treatment is to eliminate the internal stress generated during the blank manufacturing process, improve the cutting performance of metal materials, and prepare for the final heat treatment. The preliminary heat treatment includes quenching and tempering, annealing, normalizing, etc., which are generally arranged before and maybe after rough machining. And for this arrangement, before roughing can improve the cutting performances of the materials or something like that. And arrangement after rough machining is beneficial to eliminate residual internal stress. And for the final heat treatment, the final heat treatment should generally be arranged after rough machining. It's like semi-finishing and before and after finishing. And heat treatment with large deformations such as quenching and tempering, etc., should be arranged before finishing. It cannot be done after finishing, so as to correct the heat treatment during finishing deformed. Heat treatment with less deformations such as nitriding can be arranged after finishing. The overall quenching and surface quenching process position arranged is basically the same. Yes, Laushi.
Okay, so tell me what's your number?
Laushi, 64.
64. Okay. Okay, it's time. So where are you now? 64.
In Bangladesh.
So I cannot hear you clearly. So okay.
Monchelago.
Oh, seems far. Okay, it's time to finish the class. Thanks for cooperation. See you next Monday.
Okay, Laushi.
Bye.
Bye-bye.
Bye, Laushi.
Laushi, don't forget to send PPG, please.
Okay.
Actually, I have to send it direct in your email.
Yeah, not through the WeChat. Please send the homework through the email address.
Okay, Laushi.
Okay, thank you.
Okay,
See you.
thank you. See you.
Okay, bye-bye.
See you, Laushi.
See you.
Which one?